All right, let's get into some conditional probabilities. You've actually seen conditional probabilities in Algebra 1. We just didn't use this really fancy formula. We just more focused on the words and what those words were asking us. So let's look at this conditional probability formula. The conditional probability of B given A. So that first line there, okay? So the probability of B given A, that's how we read this. This little line right here means given. B given A happened, okay? So that's the probability of event B occurring, given that event A occurs. So when we see given A, that A becomes my denominator. Okay, so right here, A has to happen. Okay, that's my condition. I'm just looking at a small population. I've shortened that condition. This is my condition. Okay? So if A happens and then B happens, that's where that intersection, that's how we label it, that intersection. Since A is happening, it has to be happening while B is happening. There's an intersection. Let's look at some examples here. So let Q be the event that a card is a queen, and let R be the event that a card is red. You are asked to find queens given red. But first, let's find the probability of their intersection and the probabilities of red. So there are how many red queens in a deck? 2. Remember, there's 2 red suits. So if you don't remember this, we have 4 suits. We have clubs. I'm just going to put B for black. We have spades. B for black. We have diamonds. R for red, and we have hearts. R for red. In each one of these, we have 13 cards. And out of those 14, 4 are face cards. So we have a queen and a queen, so that means there's 2 queens out of 52 decks of cards. So we can write that probability as 2 out of 52. And we'll wait to simplify at the end. How many red cards are in a deck? Well, we have 2 suits of red cards, so 13 plus 13, there's 26 red cards in a deck of cards. So the probability of red is 26 out of 52. And again, we'll simplify at the end. So let's put this all together. So the probability of a queen given red, so we put that whole red, I'm going to put this whole red fraction on the bottom. So 26 out of 52. Their intersection was 2 out of 52. Multiply the numerator and denominator by 52. So when I multiply here by 52 and here by 52, these denominators cancel in my fraction, so I'm left with 2 out of 26, which simplifies to 1 out of 13. So as I move through more examples here, I'm going to skip these steps. I'm just going to get to here, because this still means their intersection. It's out of the same total, so that step's not necessary. It's out of the same total, so I have 2 that are reds and queens out of 26 total red cards. Okay, that's my condition. And I've simplified it, so the probability is 1 out of 13 cards. So I'll let you reflect on those questions. You can think about those and ask me questions if you need to. Let's look at the next page here and do some more examples. I'm going to skip the top part. I'm not going to make too many tables. I want to practice more on the notation first. So I'm going to scan through this. All right, let's look at the bottom, 4 through 9. So consider a deck of playing cards and the following events. A is an ace, B is a black card, C is the card of clubs. Find each probability as a fraction. So remember that this line means given. And it's given this condition. That's going to be my denominator. So, given black cards. So how many black cards are in a deck of cards? Okay, it should be 26. Out of those 26 cards, how many are aces? So how many black aces are there? There's 2. I'll write it up top. So we have 1 out of 13 again. Okay. Let's look at the next piece. Okay. So we have given an ace. How many aces are in a deck of cards? 4, 1 in each suit. Out of those aces, how many of them are black? 2. And that equals 1/2. As you answer these questions, if you can't imagine these deck of cards, I will upload an image of a deck of cards that are flat. Here, I'm just very familiar with the deck, so I can answer these questions quickly. Okay. Given a club, there are 13 clubs, because that's 1 suit. Oops. There are 13 clubs, because that's 1 suit. How many of those are aces? How many clubs are aces? Just 1. So that probability is simplified here. All right. What about given an ace? Again, there's only 2 aces in a deck of cards. Or excuse me, there's 4 aces in a deck of cards, 1 in each suit. How many of them are clubs? 1. Okay, there's 1 ace of clubs. All right, so given clubs again. Clubs is a suit, so we have 13 cards to look at. How many of those clubs are black? Well, clubs are a black suit, so all 13. That's 1 or a 100% chance. Last example here. Given black, there are 26 black cards. So we have clubs and we have spades. Out of those, how many are clubs? 13 or 1/2. Notice all of my probabilities are fractions. Okay, the directions even say find each probability as a fraction. Okay. Tune into the next video for more step-by-step examples and practice on conditional probabilities.